Here we are, folks, with a apparently simple question about vector quantities. Feel free to take a look and then hit play when you're ready to see the explanation. Okay, hopefully you've had a try at that. Now, like I said, this is one of those questions which looks on the surface fairly simple, but when we dig into some of the maths or the physics of it, then we might actually find that it's a little bit more of a challenge. Okay, so what we're going to do is we're going to look at these quantities all in terms of equations. All right, so let's start with acceleration. Now, acceleration, you hopefully are aware that A is equal to V minus U divided by T. Now, on the top there, we've got a vector, and that's our velocity. Okay, and we've got a scalar on the bottom, that's our time. Now, vectors have magnitude and direction, and scalars just have magnitude. And the effect of that is when we take a vector and divide it by a scalar, we get another vector. So the answer here is A. Okay, but the question is, why does that kind of not work for the other equations? Let's take an example with energy. You might be aware that energy is equal to m times g times h. You can do this with any equation. Well, mass is a scalar, g, which is a number, is a scalar, has no direction, and h is a number as well. Height is just a number, and so therefore we have scalar times scalar times scalar, which produces another scalar. Okay, so therefore energy is not a vector quantity. We can rule that out. For speed, we're going to jump over pressure just now and come back to that. For speed, well, we should know that speed is distance over time. And notice here I'm using v for speed, but d for distance, not s for displacement. Well, why do we do that? Because distance is a scalar. We don't need to know the direction. We're dividing that by another scalar to get another scalar. And so therefore, speed is out. Now, the interesting one here is pressure. Pressure, you may be aware, is the ratio of force to area. And so some of you might be saying, well, that's exactly the same as our top one there. We've got pressure equals force over area. And on the surface, that looks like a vector divided by a scalar. Well, in IB, that's not the case. When you're calculating pressure, you're actually using the magnitude of the force, not force as a vector quantity. And so therefore, we've actually got a scalar divided by a scalar, which is why we end up with another scalar quantity, which is the pressure. Now, this is something specific to IB. They treat pressure as a scalar quantity.